Hello, everyone. I see that we have, still few people coming in, so we'll let maybe a minute before actually starting the webinar. But for those who are already there on time, thank you for joining. Okay, good. So let's start the webinar. Welcome, everyone. Maybe good morning, good afternoon, good evening. Welcome to our webinar in partnership with SolidSand about qualification of standard software library in the context of 26262. So my name is Vincent. I'm sales manager for CS Group Canada Autonomous System business line, and I will be your moderator today. Can go to next slide, Claire, please. Yeah. So today we'll be discussing the challenges associated with the C standard library usage in the context of 26262, and how we can accelerate your product development and commercialization by qualifying those standard libraries. So to discuss those subjects, I have the pleasure to welcome Claire, who is the Quality Office Manager at CS Group Canada, and Remy, who is the Qualification Lead Engineer at SolidSand. So we'll start the webinar by presenting ISO 26262 expectation and associated challenges regarding the usage of standard software library. And we will focus on the C standard library because it's one of the most commonly used in our industry. So this first topic will be discussed by Claire, who has more than 20 years experience in the automotive and aerospace industry. She has been supporting our clients from the automotive and aerospace and bringing several projects to certification. Her expertise ranges from defining the right certification strategy from the beginning of the project down to the product development, down to the qualification of several toolchain and software library for which she presented the report and the safety case to the certification authorities. So after the theoretical part and this introduction, Remy will demonstrate how you can tackle those qualification challenges with SuperGuard. So SuperGuard is a C library qualification suite developed by SolidSand, and it really accelerates the certification or the qualification of standard library and accelerate really, I mean, you can get to the certification and the finish line faster. So Remy joined SolidSand in 2018 to productize his rich research on compiler development and optimization. His main focus at SolidSand is on leading compiler qualification project for functional safety, but he is also responsible for qualifying compilers and standard libraries following the 26262 requirements. So if you have any questions during the webinar, please hit the Q&A button at the bottom of your screen to submit your question, and I will make sure to redirect them to Claire and Remy at the end of the webinar during our 10 or 15-minute Q&A session. Claire, if you can go to the next slide. Thank you. So before jumping into the technical details, I just want to take a minute or so to present CS Group Canada. So we're part of a global corporation, public organization headquartered in Paris, and our mission at CS Group Canada Autonomous System business line is really to accelerate product development from the first MVP to the commercialization of your product. And we do that by implementing and following some standard and guidelines such as the ISO 26262 for functional safety, the ISO 21434 for cybersecurity, ISO 21448 for the safety of the intended functionality, SOLIF, and the ASPICE for quality management system. So we have more than 150 engineers in North America. And those engineers have been supporting for more than 20 years now OEM system makers and high-tech startup in their functional safety certification challenges. So a group that really brings value to our client is our functional safety and cybersecurity office, which is a group of 30 experts all certified by TÜV. And they really bring high-end value to our clients. And if we look at the customer journey on the right of the screen, we can see that the journey usually starts with a gap analysis. So the gap analysis is an activity where our experts come to your facility and are going to audit your product and processes to define the optimal path toward the certification. And after that, they work hand in hand with your product development team, providing mentoring and training along those steps. So then based on that, they can act as your functional safety manager and define the right plans and processes, reusing CS Canada templates to accelerate and ensure that you have the right tool chain to bring your product to the certification. In terms of product development, so we have a product development team with about 100 engineers that have expertise in system, software, and hardware. And they're able to take a work package based on the statement of work and develop and formally test your product per the 26262 requirement. And at the end of this journey, we are also able to provide support for the certification phase. So doing the verification and confirmation review and presenting the safety case for your product on your behalf to the certification authorities in order to commercialize it. Claire, you can go to next slide. Thank you. So before giving the hand to Claire, I just want to mention that the webinar is recorded. It will be available on our website after a few days, and you can find other content, other webinar that we did in the past, ranging from webinar on ASPICE, ISO 26262, VectorCast integration to CS Canada CI/CD platform, or even discussion on how to certify safety element out of context. We also have a great agenda plan for 2022. So please visit our website, follow our LinkedIn page, or register to our newsletter to be up to date with those events. Thank you, everyone. I wish you a great webinar. We'll be seeing each other at the end for the Q&A session. And Claire, you can go ahead.
Thank you, Vincent. So as Vincent said, I'll start with the ISO 26262 introduction, and Remy will go into detail for a solution today. I wanted to have a slide for ISO 26262 to introduce it very quickly. It's not one slide to summarize the ISO 26262, of course, but just to highlight and concentrate on what we want to speak today. So basically, international standard, speaking of road vehicles for functional safety. It covers all of the product from the system to the hardware and the software. It's related to safety, you know that. And the development cycle is a VW cycle. The first V would probably represent the system, and the two side of the W for the software and the hardware. So we're speaking about three major phases here for the ISO 26262. The first one is the concept phase, and it's covered by the third part of the ISO 26262. Then we have the product development phase with the system level, which is covered by the development at system level, which is covered by part 4. And we have the part 5 and part 6 that are speaking about development for the hardware level and the software level. And then we enter the production and operation phase, where we have part 7 for all these activities and all these subjects. And in parallel of that, you have what we call the supporting processes, which is covered by part 8. And today we're going to enter into detail for the part 6, software development, and a portion of supporting process for qualification of the components. So if we enter the software side of it, software certification, we have this cycle in there. We're starting with the planning activities, with the process, the strategy, we decompose that. And then we're starting the development of the software. And we have 3 phases: the requirements, the architecture, and the design and the code. Then we have the verification side of it with the unit testing, integration testing, and qualification testing. All of this is supported by documentation. All of those phases are and need a document. So we're going to find the plans at the first portion of the first phase of software development, and then you have software documentation to have the list of requirements, the traceability aspects. All of that is contained in the software documentation, and the reports to conclude on all the verification and validation activities. Of course, you can cycle between development and verification all along your development, and you can do that in several ways, per feature, per details, per components, depending on how you develop your software and how you wanted to, add more details in it and what to present at one time. At the end, everything is there, of course, but you're cycling, and it depends on your, I would say, management way of doing your project. So now we develop the software, and what I wanted to present here that you can use libraries during your software development, or you can use tools. The first thing is tools. What about tools? It's used to simplify your development, accelerate, automate some phases. So you use tools for that. Most of the time they are used to write test cases or support the development of the requirements, for example, or even the design. And to do some of the analysis like structural coverage, static analysis, things like that, you are using tools. So every time you are using a tool, you have to evaluate if you need to qualify and, of course, proceed to the tool qualification. But today, we won't speak in details about that. What I want to speak today is enter into the usage of the libraries. So why are we using libraries is because we decompose our software. Same idea of simplification. We decompose that. We have a list of components. We have subcomponents and we reduce components into the simple element until we decide to use standard libraries. And today, with me, we'll speak in detail on C standard libraries, but you could have other standard libraries, okay? And there is a third notion, which is the reusability of a component or a subcomponent. So I've tried to create a graph to explain that a bit to those who are visual like me. So let's say we have a software. We want to decompose the software into components. So we have several components. And for each component, we have unit or subcomponents. They can overlap and share some of the functions. That's fine. So we have other components. And in the middle of all of that, we have this little run here that could be a standard libraries. So a list of functions given by another constructor, vendor, and then you want to use that as it is. So that's where we are at C standard libraries. We're exactly in there. And for reusability, let's say you have another software and you want to reuse a portion of the first software. This is not a problem, and this is what is called reusability, but you have several things to do to be able to qualify this portion, and that's what we want to present today. So if we're speaking about reusability and component qualification, again, it's detailed in part 8 of ISO 262 in section 12. We won't go into detail on this section. I don't want to read this section, but it's just an extract here. And if you recognize the V-cycle, you'll see that you have all the steps are required to qualify a portion of your software, a component of your software, and to reuse this. So you still need processes, rules for that, and that's what we call for your software planning. So it's the same concept here. You'll need to have requirements, architecture, design and source code, and on the other side, you have to have a level of the test. So basically, when you are using a standard library, you buy that from somebody else or have it with your compiler or things like that, and you don't have all of that. Most of the time, you have, of course, the code and sometimes detailed design. You may have some rules and processes in there, a portion of architecture, and sometimes some tests to rely on, but it's really rare to have proper requirements or at least certifiable requirements. So that's a challenge for you if you want to use a standard library, to go through all of that and be able to present that as a qualification aspect. When you do that, you also have documentation, always documentation for certification, whatever software you have. So you will need the component documentation. What is the component? What is there? What are the limitations, the description, the requirements, all of that. And you have to do it out of your context of your software. So it has to be like open and describe the interfaces, things like that. It is part of the documentation. Then you have the qualification report that contains the test results of you've conducted and the conclusion regarding that. And the qualification verification report that contains not only the results of the test, but also all the reviews you've done and the results of your reviews. So all of this is required to use a library, standard library, and qualify it, and therefore use it in your software for safety purposes. All of this, as I said, is really challenging. You have a lot of challenges regarding that. You have a lot of work to do, and I've decided to put some of them here. Some of them were solids and phase them. So I'm pretty sure I'm going to enter into detail of those challenges, but just to give you an idea, for example, and I spoke about that earlier, requirements. You have these standard libraries, and they have some requirements, but are they really ISO 26262 requirements? Most of the time, it's not the case. So somehow you have to rewrite requirements to have them more clear, detailed, or testable. So that's a challenge to do that, and it's time consuming, of course, also, if you have to do that on your own. The second one I wanted to bring there is regarding code coverage. It's difficult to achieve code coverage when you don't have the full context, the full elements to do. So you're writing tests, code coverage is done from unit tests, fine, you have them. But if you don't have enough details in your detailed designs, then you won't be able to write some robustness test cases, for example, and you won't be able to have a full code coverage, which is required for some of the ISO 26262. So this is also a challenge. Find the right testing and the right level of testing to achieve code coverage. The third one is a little tricky, is regarding libraries. Sometimes they have either extensions, so they add elements, add new function by all along the time, or they have like a kind of a harness for a specific function and then say, okay, you can implement that the way you want. So if you do that, you won't have like a fixed library. You're always ongoing on that. So it's challenging because you have to requalify those all the time. So it could be time consuming, expensive, etc. And it's difficult to select and keep only the portion you really need and want to keep in mind for your software. So that's also something that Remy will present, and the limitation of the tool, of course, regarding that. But it's one of the challenges, also hard challenge here, stability. Then you also have, as a code coverage and all of that, branches unreachable. The idea of having a number that's a fact, you don't have 100% fine, but if you don't have 100%, you have to add justification. So how to add justification for your branches unreachable when you haven't developed this portion of the software, and you have to read that back and understand what has been done and how it has been developed to be able to bring the right justification and acceptable justification for qualification. This is also a huge challenge here. And the last one I brought is using C standard sometime for low-level functions. They add assembly code in them. And in this case, doing code coverage is also a challenge because a portion of it you cannot cover. So in this case, you have to buy another tool or try to do it manually through analysis, things like that. Okay. Again, another challenge here, time consuming. And what you wanted to do with this C library at the beginning is to avoid time consuming. So yeah, like you have to do the right choices. So as I said, and I want Remy to present his tool, so I will give him the chance to present the tool and probably enter into detail of all those challenges. But the solution is sometimes not to do that by yourself and use the kind of tool Solistan is presenting today. And for this, I will give Remy the hand. And if you want Remy to continue and present your tool, go ahead.
Thank you, Claire.
You're welcome.
I will share my screen. All right, there we are. So yeah, Claire has introduced you to the requirements of ISO 26262 for library qualification, as well as to some challenges. And now let's take a look at our solution, our product to tackle these challenges. I will start with a short introduction on Solid Sands. We are an Amsterdam-based company. We were founded in 2014, and we are the one-stop shop for C and C++ compiler and library validation. So we have a lot of experience in compiler and library qualification for functional safety. And that's why we're here today. Here's a short overview of our products. Probably our best well-known product is the SuperTest compiler test and validation suite. It is a test suite for C and C++ compilers. And that can be used to, Claire already mentioned, tool qualification, to qualify the compiler that is part of your tool chain. As you can see in the graphic on the right, we support all versions of C and C++. C++ 20 is currently being developed, our test suite. And that can help you to qualify the compiler and use it in your safety critical software development. Next to that, we have the SuperTest MISWA compliance suite that can be used to qualify MISWA checker software. So it's a test suite with many test programs that on one hand violate MISWA rules, but on the other hand with fully MISWA compliant software. And you can validate that all MISWA violations are detected by your MISWA checker, but also that not too many false positives are being raised. Next, there is CG Trainer or code generator trainer that is more aimed at compiler developers. And that can be used to step-by-step help you implement a new compiler backend. But most importantly, what we will focus on today, that is the SuperGuard C standard library safety qualification suite. And basically that is everything that you need for standard library qualification in safety critical product development. So basically we have faced all the challenges that Claire just mentioned. And out of that, we created SuperGuard that most importantly contains a detailed breakdown of the ISO C library specification into actual requirements. So Claire already mentioned that, the C specification is not really usable for ISO 26262 to directly use it for requirements on the library. And we will take a look at why that is the case a little bit later on. So that is why we turned the specification into actual clear and testable requirements. Together with those requirements, we of course have test specifications that describe how we validate that those requirements are correctly implemented. And together with the test specifications, there are of course actual tests that implement the test specifications and validate that the requirement is correctly implemented by your library. These test cases are all developed in accordance with ISO 26262 Part 6 that lists some recommendations on how to develop test cases. And of course, we take that into account. Out of the box, all the tests in SuperGuard have high code coverage out of the box for C standard library implementations. So this both indicates, of course, the completeness of our testing, but also if, for example, for ASIL D, you are required to achieve 100% MCDC coverage. This means that you have a very good starting point with our test suite. Finally, SuperGuard comes with a software tool that provides documentation with all the requirements and all the test specifications and also the test results. So you can very clearly see what has been tested, how it has been tested, and whether the test passed or whether they failed. So looking at the fee model that Claire showed earlier, SuperGuard indeed fits in at the component requirements level on the left side of the model, with corresponding qualification tests on the right-hand side of the model. So on the left side, SuperGuard breaks down the ISO C specification into separate and testable component requirements on the C library. And then on the right side, we have requirements-based tests with corresponding test specifications that can be used to validate those requirements. So based on these qualification tests in SuperGuard, you can then construct both the qualification report that is required by ISO 26262, as well as the proof of your code coverage analysis. And yeah, that way you can use SuperGuard to qualify your standard library for functional safety. So after this brief introduction on what SuperGuard has to offer, let's now dive a little bit more into detail about how SuperGuard is constructed. I will first start with demonstrating why the ISO C specification is not really directly usable as the requirement document for the C standard library, and why we needed to break it down into more separate and more clear requirements. After that, we will take a look at how everything comes together in the documentation that is generated by the SuperGuard reporting tool. And finally, I will guide you step by step through how to use SuperGuard for actual library qualification. So here's an example of a specification of a C library function in the C99 standard. This is the string ncopy function that copies one string in an array into another array. It takes 3 arguments. First of all, the argument S1, that is an array that is being written to. Then there's array S2, that is the string that is being copied. And then there's the size n, and that indicates the maximum number of characters that should be copied. Now, at first look of this specification, you might think that there are 3 requirements on this function. The first paragraph that is numbered, that is only a synopsis of the function. And then there are 3 additional paragraphs that describe how the function should be implemented. However, when we take a closer look at this, we will see that this is not really a list of requirements, and not all text here is clear enough to directly use as testable requirements. So really, we need an intermediate step of creating requirements based on this text. Now, the most problematic is paragraph number 2, and then especially the red marked text here. This description is not complete, and it's also pretty free to interpretation. Because if we read that the function copies not more than n characters, we could even understand this as if the function is free to copy any number of characters as long as it is below n. So very literally, if this function would copy 0 characters, it would still comply with this specification here because 0 is less than n, and then it is compliant. But of course, common sense tells us that this is not the intention of the function and also not the intention of the specification. But for requirements-based testing, yeah, this description is simply not clear enough. Now, what is actually meant here is that the function should copy the string that is in argument S2 with a maximum of n characters into S1. So that means that if S2 is shorter than n characters, it will copy the entire string from S2 into S1. But if the string is equal to n characters or larger than n characters, it will only copy the first n characters from S2 into S1. So when writing requirements for this function, yeah, we should make this very explicit, because only that way we can use those requirements to directly test them and verify that the function is correctly implemented. Now, luckily, not all requirements are that unclear in the C specification. There are also some directly usable requirements, and those are in paragraph 3 and 4. So in paragraph 3, the green text describes that null characters should be appended if the string is shorter than n characters that is being copied. Well, this is very clear, and we can directly use this to implement the test. And the same goes for paragraph 4 that states that the function should return the value of S1. Yeah, this is again very clear and can directly be used to implement the test. Now, based on the function specification in the standard, we cannot construct 3 requirements, but actually we constructed 6 different requirements. The first requirements here, the first 2 that are marked green, those we took straight from the C99 specification, where we saw that the specification itself was already clear enough. But the second two, the red marked requirements, those are the requirements that describe what we concluded that the function should actually copy. So this we based on the fake piece of text that stated no more than n characters should be copied, but now we make it very explicit. We split it into two separate requirements, one for copying strings with a size less than n, and one for copying strings that are equal or larger than n. So the first requirement states that if S2 points to a string with length L2 that is less than n, the function should copy L2 characters from S2 to S1. The second requirement states that if S2 does not point to a string with a size less than n, the function should copy the first n characters from S2 to S1. So this way, the requirements now make very explicit what the function should do, and now we can use them to really start developing tests. The last two requirements on this slide that are marked yellow, those are not explicitly mentioned in the specification, but we constructed them to describe in more detail how the function should behave and to more strictly verify that it is correctly being implemented. So they take into account, for example, potential errors that could happen in the implementation of the function, but also they simply state what the function should do and what it should not do. So the first yellow requirement here states that the function should not write the target array S1 beyond the first n characters, because that would be both incorrect and it would also cause an undefined behavior. And of course, yeah, that should not happen here. The second requirement that states that the function should not modify array S2, because array S2 is the array that is being copied from and not the array that should be written. Well, this should be tested, because if the implementation does this incorrectly, then the function is implemented incorrectly. So this should be made explicit. And these additional requirements make sure that the function is robustly tested and potential errors in the implementation will be detected. After defining the requirements, the next step for us is to create a test specification that describes how we implement a test that verify these requirements. And of course, based on these test specifications, then an actual test will be implemented. Here are two test specifications for two of the requirements that we just took a look at. The first one states that for the requirement that describes that null characters should be appended when a string is copied with a size less than n, it explains how we validate that. So the test specification describes that we call the function with strings, including the empty string, that are shorter than the value passed as the n parameter. Because only for strings that are shorter than the value passed as the n parameter, this requirement applies. And we then verify that null characters are appended after the copied string in S1 until n characters are written. So here we clearly state both how we test the requirement, but also which inputs were used to test this requirement. For the second test specification on the slide here, is for the requirement that says that S2 should not be modified. We don't have to describe the inputs, because this requirement applies to every single way of calling the string and copy function. So here the test specification states that for all test cases, no matter what is the exact input, we verify that the array S2 is not modified after calling the function. So now we have looked at the requirements, we have looked at the test specifications that are part of SuperGuard, and this is now where everything comes together. So after running the tests, the documentation tool from SuperGuard can be used to create a report that contains an overview of all information that is relevant to the testing of the library implementation. Most importantly, this overview provides clear requirements traceability, because it lists not only the requirements and the test specification, but also the specific section in the C specification that the requirements apply to. And also for each test specification, it is listed which test file in the test suite of SuperGuard implements the test specification. So this way, the report allows you to very clearly trace back a test file to the C specification, but also the other way around. It is very easy to see for which section in the C specification, which tests are being applied. So this requirements traceability is required by ISO 26262, and SuperGuard is very transparent about it. So now we have looked at what SuperGuard has to offer and also how, in a little bit of more detail, it has been developed. So now let's take a more practical look at how to use SuperGuard step by step to, in practice, qualify your C standard library. Well, first of all, like Claire already mentioned, there is documentation, documentation, documentation. It is very important to document exactly what you are qualifying. So in terms of library qualification, it is important to document the exact version of the library implementation that you used. So this could, for example, be a specific version of a commercially available C standard library, but it could also be a specific version of an open source C standard library like the GNU C library. Next, it is also important to document to which version of the C specification the library should comply. For example, compared to C90, the C99 standard has added many library functions, but it has also added additional requirements to library functions that already existed in C90. So it is very important to be aware of the version of C that you are qualifying for, because this specifies exactly which requirements should be verified and also which tests in SuperGuard should be used. Next, it is also important to specify which part of the C library you are qualifying. You could choose to qualify the entire C library, but yeah, the library is relatively big and not all library functions are very relevant to embedded software development. So you could also choose to limit your qualification efforts to maybe only the functions that you really use within your application, or you could select a limited set of library headers and then qualify all the functions that are part of those library headers. Now, this last option gives you a little bit more flexibility because then you could still choose later on to use additional library functions within your application that belong to the headers that are allowed to be used. But still, this will reduce your qualification efforts quite significantly. And that is, of course, always a bonus. Of course, also the SuperGuard version that you use during the qualification should be documented because that provides a reference to the exact versions of the tests and the test specifications that were used during the qualification process. And that's always important to refer back to later on. Finally, you should also document the applicable ASIL level that applies to your software, because that decides exactly what qualification efforts should be performed. Most importantly, if you choose to qualify for ASIL D, that would mean that you need to achieve 100% MCDC coverage and code coverage. So of course, yeah, it is important to be aware of that because that can influence the effort that will be required to verify your library. Now, once you have specified exactly what your library qualification efforts will look like, it is now time to configure SuperGuard to actually perform the qualification. So first of all, SuperGuard needs to know how a test should be compiled. You need to configure the compiler command that should be used, as well as the compiler options that should be used. Now, in the image on the right here, you see we specified the GCC compiler, and we told it to compile the test using the standard C99 option. In terms of functional safety, it is very important that this is a qualified compiler because then you are sure that the compiler is safe to be used and that the tests are being translated in a correct way. Next, the SuperGuard test driver also needs to know how a compiled test should be executed. And to do that, our test driver can be scripted using Python. So you could, for example, create a script that flashes your hardware target and then initializes a debugger session, runs the test and retrieves the test result and gives that back to the test driver. Finally, you should specify which tests in the SuperGuard suite need to be executed. And this is then, of course, based on the subset of the library that you decided to use in the previous step. In the example here with the item test set expression, we selected the C99 library, but we subtract all the tests that are for wide character functions in the C99 library. So SuperGuard makes it very easy to define your own subset of tests. And of course, that is very useful when you only qualify a subset of the library. Finally, important to note here is that SuperGuard can be configured for basically any environment as long as it is C or C++. We also have many example configurations available, so we are always happy to help you get started as soon as possible. Now, after configuring SuperGuard, it is of course time to run the actual tests. The test driver is fully automated after configuring it, so basically it's pushing a button and waiting for it to complete. But especially in terms of ASIL-D, an additional step might be required to achieve the 100% MCDC coverage. I mentioned before that SuperGuard has high structural code coverage out of the box, but of course each library implementation is different. So it might mean that for your specific library implementation, some specific branches are still not covered by the tests. In that case, you would need to extend some test cases, but luckily that is not very complicated because SuperGuard is just a bunch of C programs in the basics. So it is easy to extend if you have any C experience. That should not be a problem at all. After completion of running the test, then the SuperGuard documentation tool that we looked at before can be used to create the list of requirements, test specifications, and most importantly, the test results. And then the next step is actually analyzing those test results. So after running your tests, as you can see in the graphic on the right, it is quite likely that you will find some red, which means that some tests have failed. We found that most common library implementations are pretty good, but no library implementation is perfect, so there will always be some errors that you need to analyze. Now, in case of an error, it is very important, of course, to know exactly what is going wrong. And once you know what is going wrong, it is very important to define a mitigation for that issue. So defining a mitigation means that you have to define a workaround that explains how you make sure that your application is not impacted by the issue that was found. So for example, this could mean that you cannot use the library function with a certain kind of input, or in rare cases, if it is too difficult to define a clear workaround, it could mean that you cannot use the library function at all. Now, based on the defined mitigation, it is then important to analyze your application to make sure that the mitigation is being applied. And to do that, you could, for example, use static analysis to scan for the use of the library function. And then you would make sure that the function is not used in a way that incorrect results are being obtained. Preferably, this would be an automated solution because then there's no human error involved, but also then you can quickly analyze your application again when you are making changes. And that will, of course, on the long term, save you a lot of time. Well, let's look at a short example of defining mitigation for a hypothetical problem. So let's imagine that SuperGuard finds for the string encopy function that the requirement return is not correctly implemented. And after analysis, you find that the function incorrectly returns the value S2 instead of the value S1, which it is required to return. Now, the mitigation then would be that your application should not rely on the return value of the function, but instead it should use the pointer that was passed as the first argument, S1. You should use that pointer to retrieve the result of the string encopy function. You would then scan your application for usage of the string encopy function and make sure that your application does not use the return value of the function, but instead uses that pointer. Now, after running the test and after analyzing the results, we have now come to the final step, and that is creating the actual qualification report. So the qualification report will contain a description of everything you have done in the previous steps, and you describe what you did, how you did it, and why that is compliant with the requirements of ISO 26262. ISO 26262 also requires you to describe the development process of the library. Well, that can be quite a challenge because it is not always that clear. I mean, if you got your C standard library from a commercial vendor, they might provide it as part of the documentation. But for open source library implementations, it is often unclear and not available. However, from experience, we know that there are ways around this, for example, by describing high-level the high-level process of open source software development. For example, that it uses version control and very strict code reviews. And from experience, we know that this is often accepted by certification authorities. Well, most importantly, of course, when creating the qualification report, you should describe the test results that you obtained. So especially the failures that you found, they should be described in the qualification report. And also the mitigations that you defined, they should be part of the qualification report. And this part of the qualification report then forms the safety manual for the library. So the safety manual would then be used by your application developers to make sure that they use the standard library in a safe way and in a way that is compliant with ISO 26262. Finally, together with the qualification report, you should also store all evidence that was used to create the qualification report. In case of using SuperGuard, that would be the raw log files that come out of our test driver, as well as the SuperGuard report with the requirements and the test specifications and the results that you use to create the qualification report. Because this information is basically the entire information that your qualification report is based on. So it is important evidence that can later on be used to assess the completeness as well as the correctness of your report. And with that, we come to the end of the step-by-step plan of using SuperGuard. And after step 5, we have a qualified library for ISO 26262. So as a short recap, SuperGuard is a requirements-based test suite for the C standard library. It has high structural code coverage and MCDC coverage out of the box. It creates very clear reports with linking requirements, test specifications, and test results. And of course, this way you will be compliant with the requirements of functional safety standards. Thank you very much. And let's go back to Vincent to see if there are any questions.
Yeah, thank you, Remy, and thank you, Claire, for the great presentation. We have 4 questions here. If everyone has some question on top of their mind, feel free to to use the Q&A button. But maybe the first one, I'm a bit intrigued because we may have someone not working in the automotive industry or not working only in the automotive industry. So the question is, if I develop a component for other domains such as medical or aeronautic, can I reuse it without qualification for the automotive certification? I don't know who want to jump on that, maybe Claire?
Yeah, I'll take this one. Basically, what is magic or nice from ISO 26262 is that accepts the fact that if you use a component or a library or a portion of a software and you certify it or qualify it through another standard regarding safety and only safety, of course, they accept it. So you just have to transfer it and do a minimum activities to demonstrate that it was certified through another standard regarding safety, and they will accept that. So minimum work to take this component and bring that to the ISO 26262 and qualify right away for your software certification. So it is something that has been done in the past and will be done again for, as you said, Vincent, some people are developing on aero and then they come into the automotive section and want to use a piece of their code, they can do it. Absolutely.
And Remy, maybe a comment on how the SuperGuard tool can be used to achieve this objective. Is this something that you had in mind while developing the tool?
Yeah, absolutely. So I agree with Claire. I think most functional safety standards, they are actually derived from the IEC 61508 standard, so the basic industrial standard. So yeah, maybe the wording is a little bit different, but also for library qualification, all functional safety standards have the same main ID. So we are compliant with those. And of course, also for other functional safety standards, SuperGuard can be used.
Okay. Thank you, Remy. Thank you, Claire. And then we have 2 questions from the same person. And this one would be directed to Remy. The first question is, do you plan to support C++ or other standard libraries such as Python with SuperGuard? And the question, the other question is, which C standard library implementation are supported by SuperGuard? So maybe you can answer the two together.
Yeah, I can do that. So yeah, the question about C++, that is a question we get a lot because yeah, C++ is quite a hot programming language within the industry. But yeah, compared to the C standard and the C standard library, the C++ standard library is enormously big. I already mentioned that the C standard library is big, but yeah, compared to C++, I wouldn't say C is peanuts, but it is a lot smaller. So to come up with a product that solves everything at once, that is not something that we plan to do. Instead, we plan to work together with our customers and see which parts of the C++ library are relevant for them, and especially in the automotive industry and other functional safety industries. Yeah, there might be a common basis for the C++ standard library, and we would like to start from there. So right now we are already working on that with some customers actually. And yeah, we are making good progress on at least supporting the most popular parts of C++ standard library.
Okay.
Now, coming back to the question about which implementations of the C standard library we support. Yeah, basically we support them all because for us, the basis is the C specification that describes what the library function should do. So how they are implemented, that is not relevant for us. We verify that the requirements are met by the implementation. So yeah, we support them all, and our test driver can be configured as well to support them all.
So that's good news for
Absolutely
all of our customers and the people attending the webinar. So the last question, except if someone else is going to as another one, is I develop a component for a certified software. Can I consider it qualified for another software? So I'm not sure to understand really the question, but maybe Claire or Remy, you want to maybe detail and comment on the question?
Yeah, I'll start with this one. It's like the slide I've shown sooner with the two softwares and their overlap one of the components. It's this context basically. So you develop a portion of your software, your component on the software, and you want to use it again on another one, but you want to qualify it. So you want to reuse for several others. But when you develop that, you haven't started like creating a library or something like that. That's my understanding of this component. So how to bring that as a qualification to be able to use it on other software, that's how I'm going to interpret the question. Basically, it's just taken out of its own context and create what is necessary to bring it out of context. So you're going to speak about its interface, how to use this component, on which ranges, for example, it is acceptable to use it, things like that. So you're going to add more detail around your component to have it out of context, and then you qualify it the way we've done, but you have all of the elements to qualify it since you developed that as a safety concept. So you have the testing, you have the requirements, you have all of the challenges we spoke about already done through a software. So you just have to take that, put around what is necessary to have it out of context, and then qualify it. So it's not free, like you take it, you use it again. It's just you have to put a bit of work around it, but it's short and you can do that like easily.
Yeah, so it's all about planification again, and do the right work at the right time early in the process to be able to do some reuse later on.
Absolutely.
Okay, thank you, Pierre. So I don't have any other question in the chat, so I think we can. I can conclude and first by thanking Remy from Solid Sand, Claire from CS Group Canada, sorry, and thank you for your presentation. I hope that everyone was pleased by the content, and as I mentioned, we have other webinars coming up in 2022. So feel free to follow our LinkedIn page, subscribe to our newsletter, visit our website to have this content delivered directly to you. So thank you everyone again. Ami, Claire, all the attendees. It was a pleasure
Thank you,
to
Vincent.
be here today. Okay, thank you everyone. I forgot that we are in a webinar and you know, we are the only one able to speak. Okay, bye now.
Thank you. Bye-bye.
Thank you very much.